In this video, we'll be talking about angle measure. Now, before we get into a lot of the computation and calculations, we got several definitions we need to look at and talk about and discuss before we move ahead. First of all, ray. What is a ray? We're referring to a ray there. A ray is a part of a line. It has one endpoint and extends infinitely in one direction. So if we are referring to a ray, it would have an endpoint and extend infinitely in one direction. Thus, the cause or the need for an arrow at the end of it. So it has an endpoint. We could call this A and this B. So that would be ray AB. Notice the facing of the arrow. Always the arrow will face to the right, and we'll always read it as we would state it. The endpoint is always that first letter. So if we were to happen to have a ray that started here and went up, let's use the right. Tool. There we go. And if we had the following letters, say we have Z and point Y. This would be ray ZY. We do not go in alphabetical order. We always start at the end point and go through towards the arrow as we state it. The arrow never points to the left. We always read it and state it and write it as the arrow is to the right-hand side. Now, opposite rays are two rays that share a common endpoint and are collinear. So if I wanted to draw a ray this direction and a ray in this direction, my tool is not working for me just right. Hey, there we go. Holy goodness gracious. Let's back up. There we have it. Notice in this particular one, we have the common endpoint of C, and we're going to call this D. Let's call this side or this point B. Ray CB and ray CD are opposite rays. They share a common endpoint, which is right here, and they go in opposite direction. They're collinear. Notice opposite rays go in opposite direction. A ray or two rays that share a common endpoint and non-collinear, we will look at those right now. What are those? Those are what we discuss and call and talk about as being an angle. So if they share a common endpoint and are non-collinear, it would look something like so. And thus we have an angle. An angle would have the following points located on it. Let's call it A, B, and C. So this would be angle ABC. A couple of things here. The rays, so I have the two rays of ray BA and ray BC for this angle. These are known as the sides of that angle. And the common endpoint of the vertex, where both rays meet, that is known as the vertex. So we have the sides of BA, ray BA and ray BC, and we have the vertex of B. Now, there are a couple of ways that we can name this angle. First of all, or the one way we can name this angle is by all the letters. Notice the order that we went in. The vertex is always the middle letter when we're naming an angle. So this could be right angle ABC. We could also reverse that and say that this is angle CBA. Notice vertex is always the center. If there are not multiple angles here, we can just call this, in other words, if there's only one angle, we can call this angle B. And if we have a number inside of it, we could call this angle 1. So 4 ways to name this one singular angle. We have to be careful with this way of naming the angle if we have multiple angles at one location. And we'll discuss that a little bit later on. So, angle, different parts. We have ray, opposite rays, an angle, what is an angle, and the different parts of an angle. So we have different types of angles. First of all, we have what is called a right angle. A right angle is an angle whose measure equals 90 degrees. So we could have an angle, and we know that it's a right angle because it usually, or it does have that little box in the corner that signifies that it measures 90 degrees. An acute angle is an angle whose measure is less than 90, so something like so would be an acute angle. Obtuse is greater than 90, so here's my angle. Greater than 90 degrees, but it's less than 180. And a straight angle, guess what? That is the straight angle. Here would be the vertex of that angle, and so we're looking there at the angle. Notice that what is a straight angle? It is a line. So a line has a measure of 180 degrees because it is a straight angle. So there's our 4 different types of angles when classifying them. So let's name a few. Let's look at the following drawing. Notice that we can see that we have a red box, and a lot of time it is red signified. So we can see that if we wanted to name a right angle, there are 2 right angles. Now we cannot just name any of these angles by angle F. Why? Because there are 1, 2, 3, 4 angles, plus we have angle 5, 6. There's a lot of different angles in this. So that's the reason why we cannot just name it by angle F. Anytime, let me stress to you, if there are multiple angles at a vertex, here is our vertex. If there are multiple angles at that vertex, you have to use multiple letters to name that angle. So if I wanted to look at naming a right angle, notice here is my right angle. I have angle CFE. So angle CFE would be my right angle. If I wanted to name an acute angle, I have 1, 2, 3, 4. I have 4 different acute angles. If I'm naming it by letters, I have angle DFE. That is another way of saying angle 4. Angle DFE. Angle 4 is an acute angle. An obtuse angle, remember, is larger than 90 degrees, but less than 180. So I've got 2 different angles. I can look at angle BFE, which is this whole angle. Angle BFE is obtuse. We also have another angle. If I wanted to look at this angle here from A all the way over to here, so I have angle AFD. That is also AFD, an obtuse angle. And there is only one straight angle here, and that would be angle AFE. Is my straight angle. So being able to look and classify and identify the 2 different angle types. A couple of more important things to know. 2 angles that have the same measure are congruent angles. 2 angles that have the same measure are congruent angles. We do use the symbol, an equal sign with a little squiggly on top. You'll hear that mentioned a lot. That is what we use for congruent. So if I know that angle A, B, C is congruent to angle, say, XYZ, then I can conclude their measures are equal. That means if angle ABC is 45 degrees, then angle XYZ is 45 degrees. Because when we're measuring angles, we do measure in degrees. There's a total of 360 degrees in a complete rotation. And we use degree, always put our degree markings there. So congruent angles have the same measure. An array that divides an angle into 2 congruent angles is called an angle bisector. And the way that we see that, if I have angle, let's call this DEF, and I tell you that ray EG bisects EG. So EG is supposed to be a G, not a E. So ray EG bisects angle DEF. That means that ray EG divides this angle of DEF into two congruent angles. Therefore, this angle is congruent to this angle. This angle here of DEG would be congruent to angle FEG. And you will see that marked. They will have the same number of markings or arcs to signify that they are congruent if it is not told to you. So if we know that we have an angle bisector, we can put that into practice. Say that I have the following. Let's use DEG or DEF. I said G, and this is point G. We know that this is 2x plus 3. And over here, we know that this angle is, let's say, x plus 8. So angle DEG is equal to 2x plus 3, and angle FEG is equal to x plus 8. We are told that EG is the angle bisector, solve for x. If EG is the angle bisector, therefore we know that angle DEG is congruent to angle FEG. That means their measures are equal, thus we can substitute and we can solve. Solving for x, I'm going to subtract x here. So we're left with x. And at the same time, I'm going to subtract 3. Cancels, cancels. So therefore, x is equal to 5. Now, x is equal to 5. So if we're asked to solve for x, we have solved for x. It may sometimes ask you to plug back in and solve for the missing angle measure. Well, what is the measure of angle DEG? We're going to substitute back in. Well, we know that DEG was 2x plus 3. What was x? X equals 5. Therefore, the measure of the angle is 13 degrees. And if we did our math correctly, angle GEF is equal to x plus 8. 5 plus 8 equals 13 indeed. Notice 13 and 13, they are congruent. If the directions by some chance happen to say, what is the measure of angle DEF? Since this is an angle bisector, we can add them together, and thus angle DEF would equal 26 degrees, 13 plus 13. So there is our lesson on angle measures.